NENOMATICA, where mathematics meets YouTube excellence. Welcome to our mathematics video on simplifying algebraic expressions. Today, we'll work through two examples step by step, showing the complete solution process. Let's start with our first example. We need to simplify the following expression: 2a cubed minus a squared plus 3a multiplied by 2a cubed plus a squared plus 3a. Let's identify the pattern in this expression. This is a difference of squares pattern in the form of a minus b times a plus b, which equals a squared minus b squared. Now, we can apply the difference of squares formula. Using our identified a and b values, we have a squared minus b squared. Let's square each term. For the first term, we get 4a to the sixth power. For the second term, we need to expand the square of a binomial using the formula a plus b squared equals a squared plus 2ab plus b squared. Next, we'll distribute the negative sign to all terms inside the second parentheses. This gives us 4a to the sixth power minus a to the fourth power minus 6a cubed minus 9a squared. So our final answer for the first example is 4a to the sixth power minus a to the fourth power minus 6a cubed minus 9a squared. Now, let's move on to our second example. We need to simplify the following expression: open parenthesis 1 plus 2 a close parenthesis times open parenthesis 2 a minus 1 close parenthesis times open parenthesis 4 a squared plus 1 close parenthesis. For this example, I notice that the first two factors have a special form. If we rewrite 1 plus 2 as 2a plus 1, we can see that these two factors are in the form of a plus 1 times a minus 1. Now we can apply the difference of squares formula to the first two factors. The product of 2a plus 1 and 2a minus 1 equals 4a squared minus 1. Now we have the product of 4a squared minus 1 and 4a squared plus 1. This is also in the form of a minus b times a plus b, where a equals 4a squared and b equals 1. Applying the difference of squares formula again, we get a squared minus b squared. Therefore, our final answer for the second example is 16a to the fourth power minus 1. Let's summarize what we've learned. In our first example, we used the difference of squares formula to simplify the product of two brackets, and then expanded the squared terms. In our second example, we recognized a pattern in the factors that allowed us to apply the difference of squares formula twice, resulting in a very elegant final expression. Remember these key algebraic patterns: the difference of squares, a minus b times a plus b equals a squared minus b squared. The square of a binomial, a plus b squared equals a squared plus 2a b plus b squared. Practice identifying these patterns and expressions to simplify your calculations efficiently. Let's solve this first expression: 2a plus b minus 5c multiplied by 2a plus b plus 5c. Let's start by rewriting this expression. Notice that we have something that looks like the difference of squares formula. We can rewrite this as the quantity 2a plus b minus 5c times the quantity 2a plus b plus 5c. This is in the form of u minus v times u plus v, where u is 2a plus b and v is 5c. Now we can apply the difference of squares formula, which states that u minus v times u plus v equals u squared minus v squared. In our case, u is 2a plus b and v is 5c, so we get the quantity 2a plus b squared minus the quantity 5c squared. Now we need to expand the squared terms. For the first term, we use the square of a binomial formula: u plus v squared equals u squared plus 2uv plus v squared. So 2a plus b squared expands to 4a squared plus 4ab plus b squared. And 5c squared is simply 25c squared. Let's move on to our second example. We have the expression x plus 1.5 times 4x minus 6 times 4x squared plus 9. Let's start by factoring out common terms. Looking at 4x minus 6, we can factor out a 2 to get 2 times the quantity 2x minus 3. So we can rewrite our expression as x plus 1.5 times 2x minus 3 times 4x squared plus 9. Now, we'll rearrange the expression further. Notice that 2 times x plus 1.5 equals 2x plus 3. So our expression becomes 2x plus 3 times 2x minus 3 times 4x squared plus 9. Looking at the first two factors, we have 2x plus 3 times 2x minus 3. This is in the form u plus v times u minus v, which equals u squared minus v squared. In this case, u is 2x and v is 3. So we get 4x squared minus 9. For our final step, we again use the difference of squares formula, but in reverse. We have 4x squared minus 9 times 4x squared plus 9. Using the formula u squared minus v squared equals u minus v times u plus v, we get 16x to the fourth power minus 81. Let's look at our example. We need to find the value of the expression by using the product of conjugate pairs. Let's solve this step by step based on the algorithm. The first step is to rewrite the expression. We have 3 over 2 times 2 over 3, multiplied by the 3 factors. In the second step, we simplify 3 over 2 times 2 over 3, which equals 1. Then we expand the first factor. We can rewrite 1 minus 1 over 3 and 1 plus 1 over 9 as 1 minus 1 over 9 and 1 plus 1 over 9. In the fifth step, we simplify further. We have 3 over 2 times 1 minus 1 over 81 times 1 plus 1 over 81. The factors 1 minus 1 over 81 and 1 plus 1 over 81 form another conjugate pair. In the sixth step, we simplify the conjugate pair. Using the identity a squared minus b squared equals a plus b times a minus b, but in reverse, we get 3 over 2 times 1 minus 1 over 6,561. In the final step, we compute the result. We have 3 over 2 times 6,560 divided by 6,561. The final result is 3 times 6,560 divided by 2 times 6,561. Let's look at our example. We're going to solve this step by step. First, notice that our starting expression is 4 times the quantity 2a minus b squared times the quantity 4a squared plus b squared squared times the quantity a plus 1/2 b squared. For our first step, we'll manipulate the term a plus 1/2 b squared. We can rearrange this as 4 times a plus 1/2 b squared times the quantity 2a minus b squared times the quantity 4a squared plus b squared squared. Next, we'll focus on the term 4 times a plus 1/2 b squared. We can rewrite this as 4 times 2 times a plus 1/2 b to the power of 2 times the rest of the expression. Now we'll simplify what's inside the first bracket. 2 times a plus 1/2 b equals 2a plus b. So our expression becomes 2a plus b squared times the rest of the terms. Looking at our expression, we notice that we have 2a plus b squared times 2a minus b squared. This can be rewritten as 2a plus b times 2a minus b squared. Now, we'll use the difference of squares formula. 2a plus b times 2a minus b equals 4a squared minus b squared. Our expression now contains 4a squared minus b squared squared times 4a squared plus b squared squared. Let's rewrite this as the product of these terms, squared. Again, we can use the difference of squares formula in reverse. 4a squared minus b squared times 4a squared plus b squared equals 16a to the power of 4 minus b to the power of 4. Now we need to expand the square of this difference. Using the binomial formula, we get the square of the first term, which is 16a to the power of 4 squared, minus 2 times the product of the terms, plus the square of the second term. Simplifying each term, 16a to the power of 4 squared equals 256a to the power of 8. 2 times 16a to the power of 4 times b to the power of 4 equals 32a to the power of 4b to the power of 4. And b to the power of 4 squared equals b to the power of 8. Our final answer can be written as 256a to the power of 8 minus 32a to the power of 4b to the power of 4 plus b to the power of 8. Let's summarize what we've learned. Today, we'll work through a step-by-step process to simplify a complex algebraic expression. Let's start with our example. We want to simplify the following expression: x minus y squared times x squared plus 2xy plus y squared times x squared plus y squared squared. Let's start by identifying the parts of this expression. We have 3 main factors. First, x minus y squared. Second, x squared plus 2xy plus y squared, which we recognize as x plus y squared. And third, x squared plus y squared squared. For our first step, we'll rewrite the expression by substituting x plus y squared for x squared plus 2xy plus y squared. This gives us x minus y squared times x plus y squared times x squared plus y squared squared. For our next step, let's focus on the first two factors. We can rewrite x minus y squared times x plus y squared as the square of their product. That gives us x minus y, x plus y squared times x squared plus y squared squared. Now, we can use the difference of squares formula to simplify x minus y, x plus y. This equals x squared minus y squared. So our expression becomes x squared minus y squared times x squared plus y squared squared. Next, let's focus on combining the factors. We have x squared minus y squared times x squared plus y squared squared. We can write this as x squared minus y squared times x squared plus y squared squared. Now, we have another opportunity to apply the difference of squares formula. X squared minus y squared, x squared plus y squared, equals x to the fourth minus y to the fourth. So our expression becomes x to the fourth minus y to the fourth squared. Finally, let's expand x to the fourth minus y to the fourth squared. Using the formula, a minus b squared equals a squared minus 2a plus b squared, we get x to the eighth minus 2 times x to the fourth times y to the fourth plus y to the eighth. So, we've simplified our original expression, x minus y squared times x squared plus 2xy plus y squared times x squared plus y squared, squared to x to the eighth minus 2x to the fourth y to the fourth plus y to the eighth. This is our final answer. Let's start with our example. We want to simplify the expression a plus b times a squared plus b squared times a to the fourth plus b to the fourth, and so on, all the way up to a to the 2n plus b to the 2n. Let's start simplifying this expression. First, we'll rewrite it by factoring the numerator. We can rewrite a plus b times a squared plus b squared times a to the fourth plus b to the fourth, and so on as a minus b times a plus b times a squared plus b squared times a to the fourth plus b to the fourth, and so on, all divided by a minus b. Next, let's use the difference of squares identity on the first term. We know that a squared minus b squared equals a plus b times a minus b. So a plus b times a minus b equals a squared minus b squared. This gives us a squared minus b squared times a squared plus b squared times a to the fourth plus b to the fourth, and so on, all divided by a minus b. Following the algorithm shown in the input, we'll continue applying the difference of squares identity. We've shown the first few steps, and the process continues in the same way. Let's skip ahead to the later steps in the algorithm, where we have a to the 2n minus b to the 2n times a to the 2n plus b to the 2n, all divided by a minus b. Next, we apply the difference of squares identity again to the remaining terms. We know that a to the 2n minus b to the 2n times a to the 2n plus b to the 2n equals a to the 2n squared minus b to the 2n squared, which equals a to the 2 times 2n minus b to the 2 times 2n. Let's simplify the exponents. We know that a to the 2n squared equals a to the 2 times 2n, and b to the 2n squared equals b to the 2 times 2n. Let's simplify the exponent further. 2 times 2 to the n equals 2 to the n plus 1. Now we can apply a special formula. We know that a to the m minus b to the m equals a minus b times the sum of a to the m minus 1 times b to the 0 plus a to the m minus 2 times b to the 1, and so on up to a to the 0 times b to the m minus 1. Finally, we can cancel out a minus b from the numerator and denominator. This gives us our final answer. A to the 2 to the n plus 1 minus 1 plus a to the 2 to the n plus 1 minus 2 times b plus plus a times b to the 2 to the n plus 1 minus 2 plus b to the 2 to the n plus 1 minus 1. In summary, we started with the expression a plus b times a squared plus b squared times a to the fourth plus b to the fourth, and so on, all the way up to a to the 2n plus b to the 2n. By applying the difference of squares identity multiple times and using properties of exponents, we simplified it to a to the 2 to the n plus 1 minus 1 plus a to the 2 to the n plus 1 minus 2 times b plus the plus a times b to the 2 to the n plus 1 minus 2 plus b to the 2 to the n plus 1 minus 1. This is an elegant simplification of a complex product. And there we have it. The final answer to our original expression is this polynomial. Thank you for watching this step-by-step solution. Let's start with our example. we need to simplify the following expression. This expression represents a product of difference of powers and sum of powers. We'll use pattern recognition to simplify it step by step. Let's apply our first step of the algorithm. We can use the difference of squares formula, which states that a squared minus b squared equals a minus b times a plus b. Looking at our expression, we can see that the first two terms, a minus b and a plus b, can be combined using this formula. When we multiply these first two terms, we get a squared minus b squared. Now, let's continue with the next step in our algorithm. We can apply the same difference of squares formula again. Looking at our new expression, we can combine a squared minus b squared and a squared plus b squared. When we multiply these terms, we get a to the fourth power minus b to the fourth power. Now, we're starting to see a pattern emerge. Let's continue applying our algorithm. We can see that each time we apply the difference of squares formula, we're doubling the exponents. So after the next application, we would get a to the eighth power minus b to the eighth power. Let's follow the algorithm to continue applying this pattern. We recognize that each time we multiply the difference and sum of the same powers, we get the difference of the next doubled power. So the next step gives us a to the 16th power minus b to the 16th power times the remaining terms. Now we're down to our last application of the algorithm. We apply the difference of squares formula one more time, combining a to the 16th power minus b to the 16th power with a to the 16th power plus b to the 16th power. This gives us a to the 32nd power minus b to the 32nd power. So our final answer is a to the 64th power minus b to the 64th power, or a to the power of 64 minus b to the power of 64. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.